Good afternoon, students. How are you doing? Am I audible and visible to all of you? Can you
Yes.
see me?
Yes.
Yes. Let. Yes, beta. Tell me. All are there in the class? Mahi, are you new in the class?
Yes.
This is the first class.
Yes, this is my first class.
Okay, Mahi. Which school are you from, Mahi?
I'm from Saga Public School, Saket Nagar.
Sagar Public School, Saket Nagar. Tell me what's happening in your school. What is the syllabus? Uh, What are you studying in the class right now?
Now we are doing the third chapter, gravitation.
Wow, gravitation. So ahead. We are a bit behind, but don't worry. We'll push up and we'll get in touch. Kaushiki, how are you? Vedansh, how are you?
I'm fine, thank you.
Fine. Okay, Kaushiki, Vedansh, tell me what we were discussing in the last class. Mai may not know that. Mai ko pata nahi hoga. You tell me what we were discussing in the last class.
We were defining rest, motion, and distance.
We were defining rest, motion, and distance. Kaushiki is always on cue, on point, right? Vedansh, what is rest? What is motion?
Rest, an object is said to be rest when it's with respect to reference point, reference frame, its position does not change with
Great,
time.
great. Nice definition. Mahi, do you understand this definition? Mahi, you there, beta?
Yes, yes.
Okay, great. Kaushiki, what did we discuss about motion? Can you just brief me?
So we were saying that motion, like it's always with reference to the it's always with reference to something else. So it's an
Something
object
else.
is in motion
Okay.
when its position changes with time.
When its position changes with time with respect to a given reference frame. Okay. We also talked about distance. Do you remember anything about distance? Let me get Mahi into the picture. Mahi, do you know what is distance?
Yes, distance is a straight path from the initial and the final position. Distance is the length of path traveled by an object.
Okay. So you have told me two things, Mahi, here. You somehow use the word straight path between initial and final, and then you talked about length of the path. Which one should I take it? Should I take the straight one or should I take the length of the path? Or are both
Length
of
of
them
the
same?
path. Length of the path.
Length of the path. Okay. That seems to make more sense. Let me come back. Let me start with distance here. I'm here at point A. I got to go to point B. I or anyone else, Kaushiki or Mahi or Vedansh. Someone is missing today, na? Who is missing today? Absent today?
Sir, Ayush Dubey.
What's wrong with Ayush? Let me. Why he's not in the class today? Chalo. Maybe he missed the class. He'll see the recording. Okay. So somebody, me, Ayushi, Ayush, Mahi, Kaushiki, someone is going from point A to point B, and now I can go in a variety of ways. I can go like this. Path. This is a path number 1, or I can go like this. This is path number 2. When I'm following different paths, I travel a path, I travel a distance. Now, how do I find this distance? I find the length of this path. I find the length of this path. Now, length of this path 2 is obviously different from length of the path 1. Do we all agree on this? Yes or no?
Yes.
That means
Yes.
distance depends on the length of path. And that is why Kaushiki, Vedansh, Mahi, if you remember, Mahi will not be there, that we denoted what letter or alphabet did we use for specifying
S.
distance? Mahi says S. Kaushiki, what was the alphabet I used for distance? Vedansh?
Sir, L.
L. Mahi?
All
L. Small L. And why did I use L? So that it always reminds me of
Length.
length. So distance, I'll always use L for a distance. Now, it's a scalar quantity. It is never negative. You always travel a positive distance. Why you always travel a positive distance? Because you go from A to B. You travel a positive distance because length is always positive. You come from B to A. Again, it is positive because length can never be negative. Yes or no? So distance is always positive. It cannot be never ever negative. That takes us to the next point of discussion. And the next point of discussion is displacement. Now, Kaushiki, Vedansh, Mahi, any idea what is this displacement? Mahi, you
Yes,
start first. Just tell me.
it is the shortest distance of the, it is the shortest length of path from the final and the initial position.
Is the shortest length of path from the final to the initial. From the final to the initial position or initial to the final position?
Initial to final positions.
Kaushiki, do you have any idea about this displacement?
The change, so like when you move something from the starting position to the ending position, the change in the length,
Change in the length.
like how much it's been moved from when it was in the beginning to when it's later now.
Okay. Vedansh, what do you think?
It is the shortest length between two positions.
It is the shortest length between two positions. Okay. Now, what do I understand listening to all of you, that you have an idea about what displacement is? I'll just try to put my thoughts here. Now, first question that I'm going to ask, I'm going to make it a more question answer based session. What type of quantity do you think is displacement? What type of quantity do you think is displacement?
It is a vector quantity.
Mahi comes with an answer. Very nice. It is a vector quantity. Now, Mahi, tell me, if it is a vector quantity, what are the two things it must have?
It will have magnitude and direction both.
It should have magnitude and direction both. Great. So far, so good. We are on the right track. The displacement must have a magnitude, right? Displacement must have a direction. Now, can you specify, Kaushiki or Mahi or Vedansh, what is the magnitude of displacement and what is the direction of displacement? I'll give you a case. The case is that I am at point A. I am at point A, and this point A will be known as, stupid phone. This point A would be known as the initial position, and this point B would be known as my final position. I could go in any random way, tuck, 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 tuck. This is how I have gone, or a person has gone. The length of this path is distance. I know it. What I'm more concerned about right now is displacement. And as Mahi told me that it has magnitude and direction, can someone enlighten me? What is the magnitude of displacement? I moved from A to B. What is the magnitude of displacement?
Magnitude is the straight path between A to B, shortest distance.
Okay, straight path. Yeah. So basically, what do I do? I may have gone from A to B in whatever path I feel like. But what do? I join a straight line from A to B. Okay. Instead of making this as a straight line, let me use one of these straight lines that I have here. This is it. This is my magnitude of displacement. This is the magnitude of displacement here. Oh, so I should not use this one. Will not look good. The red one. This is the magnitude of displacement, which is the straight line I have drawn from A to B. So the first thing that we understand, it has got nothing to do with path, right? Path was different. The straight line is always straight line. What can you say about the direction? Magnitude is the length of straight line, or straight line distance I can call it, or length of straight line joining A to B. What about the direction? Anyone has any idea about the direction?
I'm
Southeast.
not sure.
Mahi says southeast. I understand from where you are getting southeast. Yes, I understand, Mahi, how you're getting southeast, but can you be more precise? Kaushiki, you can
I'd
try.
say that I'm not sure, but you define it using the compass bearing. So south and then some angle and then east.
South and then some angle, then east. Vedant, would you like to try? It is between south and east. So Mahi is saying southeast. Kaushik is also on the same line. Do you think same, or do you have any other idea? Any other simpler way of saying it probably?
The slope.
Slope. I don't think it is simpler. It is okay. Slope. Can I just say this? The direction is from A to B, from the initial position to the final position. From A to B, like this, the direction is from A to B. A is the initial point or B is the final point. The direction is from initial point towards the final point. You draw a straight line. The length of this vector, the length of this straight line is your magnitude, and direction is from A to B. Do we all agree on this?
Yes.
Yes, sir.
Yeah.
Now, instead of saying it in such a complicated way, I tell the magnitude, I tell you the direction. Is there a much simpler way of doing it? Look on the board. Initial point A, final point B, length, the magnitude, the vector, the displacement, the magnitude is the length of this straight line, which is simply AB. The direction is from A to B. Is there a simpler way of saying it? I can just draw a vector whose tail or starting point is A, whose head is the final point B, and I just draw it with an arrow. So instead of saying this entire thing, can I simply call it the vector?
Yes.
Which vector? It is simply the vector AB. AB vector is the displacement vector. When a body has moved from A to B in any random path does not come into the picture. A happens to be the initial position. B happens to be the final position. What is the displacement of the particle? And the answer is simply
AB vector.
AB vector. It tells me both the things. What it tells me? The magnitude of this vector is length of the straight line
Yes.
AB. The direction of this vector is from
A to B.
instead of saying this entire thing, I can just simply call it the vector AB. Displacement of a particle when it moves from point A to point B is simply the vector AB. That is the simplest possible definition of our displacement. Simplest possible definition of displacement. But in your books, in your textbooks, it may not be written so simply because they will feel, I don't know, it is somehow complicated to understand. I don't know what is the complication here. In your books, how it is written, it will be written in this fashion. It is displacement. So if I want to try to write it in the language of your book. I'll say displacement is a vector quantity. The magnitude of displacement is length of the straight line AB from A to B. And the direction of displacement is from the initial position to the final position. Remember, a vector, whenever we talk about a vector, we must say both the things. We must talk about its direction. We must also talk about its magnitude. We must also talk about its direction, because if you miss the direction, you have missed half part of this entire thing, and that is going to affect you a lot. So what is displacement? From my class, what you can take away, if a particle moves from A to B, the displacement is AB vector. Simple. Everything done. Your book may not say like this. So for your books, what do you write? The magnitude of displacement vector is the length of the straight line AB, or the shortest distance between A to B. Straight line distance between A to B, whatever we want to write, you can write. So I'll just write it in different forms. For me, if I move from A to B, the displacement is simply AB vector. Nothing else I have to say. For your books, you can write this in this form. Displacement. The displacement is a vector quantity. The magnitude of displacement vector is equal to length of the straight line AB. Magnitude of the displacement vector is the shortest distance. You can call it the shortest distance, or you can call it the straight line distance. But remember, it also has a direction. The direction has to be given from initial point A towards the final point B. Instead of saying this entire thing, you can straight away say this is simply the vector AB. Do we understand this?
Yes.
Yeah.
Vedansh?
Yes, sir.
Fine. That is my displacement vector. Now, again, I'll give you a small point. If you can understand it, it is good. If you can't understand it, doesn't matter. Now, let me draw this XY. This is my coordinate axis. This is how I'm going to plot any point. The particle was at point A. Then the particle goes to point B. It follows a path, tuck, 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 tuck. This is the path. The length of this path is distance traveled. We all know it. What is the displacement vector? How do I get the displacement vector? I straight away, let me have a straight line here with the vector sign. I straight away draw the vector AB. My vector AB becomes my displacement vector. So far, so clear? So far, so good? Yes or no?
Yes, sir.
Yes.
AB is the displacement vector, and the green thing is the line or the path it is traveling. Now, to go to my previous class, I talked about something known as a position vector. What was position vector? This position vector was telling us the position of the point with respect to origin O. Yes or no? Do we remember this? I'm
Yes.
using the same position vector. I'm very picky about colors. So here I have, not good. So here I have, not good with this. Why I can't move this? Okay, here I have this, and then I have this. I have to move all these points. Just can't move him. Okay, this is my origin O. Now remember, this is your OA vector, and this is your OB vector. Your OA vector is the initial position vector. Your OB vector is the final position vector. Yes or no?
Yes.
This was your AB vector. Its initial position was OA vector. Its final position was OB vector. I can also call this as the change in position vector. What do you mean by change in position vector? His initial position vector was OA, his final position vector was OB. How much the position vector has changed? That is given by AB vector, and this AB vector is the change in position vector, and change in position vector is equal to the displacement of the particle. So whenever a particle moves from point A to point B, its position changes. The change in position vector is known as its displacement, or simply it is AB vector. A is the initial point, B is the final point, or simply it is a vector quantity which has two things. One is the magnitude, other is the direction. How you can call the magnitude? You can call the magnitude in different ways. Either you can call it as the length of the straight line AB, or you can call it the shortest distance, or you can call it the straight line distance. Doesn't matter. You're talking about the same thing. Either you can describe it by magnitude and direction, or you can simply describe it by the vector. It all depends on how you want to describe it. Am I clear? Shall we move forward?
Yes.
Yes, sir.
Okay. Now, what we will do now is try to write all these points, what we have read as important points. We'll note them down point wise and we'll try to remember them. The first thing about displacement. Displacement, what type of quantity it is?
Vector.
It is a vector quantity. That is the first thing that you must remember. What is the SI unit of vector? Well, what is the SI unit of displacement? It is meter. Do you know this? SI unit is meter. M. SI unit is meter. Now, if it is a vector quantity, it has two things. It has magnitude. And what is the magnitude? It is the shortest distance. Will you remember this? Magnitude is the shortest distance. Then it also must have direction. And that direction is from where to where?
Initial
Initial
position.
to final.
Are we all noting this down? Yes or no?
Yes, sir.
Okay. Fourth one, I can simply call the displacement vector as AB vector, or I can call it as change, delta meaning change, delta का meaning change in R का मतलब position, change in, और this symbol का मतलब vector. So this is also known as change in position vector. When I am moving from point A to point B, how much my position has changed, that is known as change in position vector. That is my displacement vector. So far so good? Yes or no?
Yeah.
Yes, sir.
Mahi?
Yes.
Okay. Now let us try to understand what all points we can derive from all these things that you've done. First thing, does it depend on path? Question answer type session. Does the displacement, if I go from A to B, let us go back here. I go from A to B in the green path. Then I go from A to B in this, whatever color is this. What color is this? I don't know the name of colors. What color is this?
Magenta.
Magenta. Okay. If I go in the magenta path, is the displacement same or is the displacement different?
Same.
Displacement remains same.
Displacement remains same. Let me make one more path. In which color I can make it? This one. I know. This is pink, na? This was pink, na? This one. No, not pink. Something else. Okay. This one. Third one. Is the displacement same or different?
Same.
What is the moral of the story?
It does not
We
depend
just
on
need
It does not depend on path. It does not depend on path. Let us write it. It does not depend on path. Then what it depends on?
straight line or the shortest distance.
change in position.
Okay. See, you are all having the same thought. Now, what happens, beta, sometimes is that the teacher or the person who's asking you a question is looking for one specific term in that question, because that specific term may mean a lot, right? You're getting my point. Sometimes the person who is asking you a question is looking for a specific term. The specific term which I was looking for here is this: it only depends on.
Shortest distance.
No, that was not the term I was looking for, Mahi. It only depends on.
Distance between initial to final position.
It only depends on initial and final positions. I don't have to say distance. It only depends on initial and final position. If your initial and final positions remain same, your displacement would be same no matter what happens. Got it?
Yes, sir.
Everyone understands this?
Yes.
Okay. Now, what will happen if the initial and the final position are same? Is that possible? Initial and final position being same?
Yes.
Give me an example.
It could go in a circle, so like a merry-go-round.
Yeah, merry-go-round, you're moving in circles. You start from one point. Well, you don't have to go in circles, basically. You can just, you are at home right
A
now.
pendulum.
A pendulum, yes. You are at home right now, or a pendulum. Pendulum is swinging. This is known as the mean position. It goes here, it comes back to the same position. Again, it goes back here, comes back to the same position. Look at the motion of this fan moving in circles. Look at the motion of the clock. The seconds hand of the clock starts from 12, goes back to 12. Minute hand, hour hand, in 1 minute or 1 hour. They can have the same initial and final position. Or I take a just vague example here. The vague example is I go from A to B, follow some path, tung 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 tung. Then I go from B to C, follow some path, tung tung tung. Then I go from C to A, follow some path, tung tung tung. What can you say about the distance travel? Is the distance travel zero?
Distance will be sum of A to B, B to C, and C to A.
Distance will be the sum of A to B, B to C, C to A, because the length of the path will only be zero if you don't move. If you move, the length is never zero. But displacement can be zero if your initial and final positions are same. So displacement can be zero or will be zero if, instead of can, I should write will. Will be zero if initial and final positions are same. Do we understand this?
Yes.
Vedansh? Mahi?
Yes, sir.
Yes.
Okay. Right. It does not depend on path. Okay. Now, as Kaushik, Mahi said that the distance from A to B and B to C and C to D. I also told you that distance is always positive. Now, similarly, in your books, you will find this term. Displacement can be positive as well as negative. Have you heard it,
Yeah.
Mahi? Vedansh?
Yes.
Yes, sir.
Can you tell me what do you mean by this? See, you must be able to explain a term if you understand it. If you can't explain it, that means there is something you have missed, and that's why probably you are not able to understand it. Can anyone make me understand what do you mean by positive and negative displacement? Distance is never negative. I told you the reason, because it is length of the path. Length can be cannot be negative. Displacement
So
negative. What do you mean by that?
if the displacement is negative, that means the final point lies before the initial point, and the direction that the displacement is in is towards the negative side. So you can find the direction if you know if the displacement is positive or negative.
Okay, Kaushiki, well done. Nice try. You're almost there. Mai, would you like to add something, Vedansh? Mai?
If we move from a point A to B, and when we are returning from B to A, at that time we are moving to opposite direction. That means we are moving to the negative side of A to B.
So that is what you mean by negative displacement, right?
Yes.
Very good. Very nice. Vedansh, your point?
The direction opposes.
Direction that opposes. Okay, I'll just give you a simple, I'll just try to put all your thoughts together and get my thought out of it. Now, when someone talks about distance being positive or distance being negative, he's only specifically talking about one condition or one
Direction.
thing. Yes. Who said that? Mai or Kaushiki?
Yes, because it is a vector quantity.
Yes. Well done. When you are talking about negative or positive displacements, negative or positive displacement means you are talking about the direction of displacement. Negative and positive only refers to the direction of displacement. Now, how does it refer to the direction of displacement? For example, I don't have to draw anything. When I go from A to B, example, when I go from A to B, when I go from A to B, Vedansh, what will be my displacement?
AB vector.
My displacement would be AB vector. It does not depend on path. It only depends on initial and final point. I draw a vector starting from the initial point to the final point, and I am there. Kaushiki. Now I come from B to A. I may have come in a different path, moving here and there, doing all sorts of funny things. What is my displacement vector now? What is my displacement now?
B to A.
So my displacement becomes BA vector, right? Yes or no?
Yeah.
What is the difference between AB vector and BA vector? If, for example, yes, if for example, your AB vector was like this, if for example, your AB vector was like this, then your BA vector would be like this. Yes or no?
Yes.
Everything remains same. The length remains same. The direction reverses. Now, if I call this AB vector as positive, my BA vector becomes,
Negative.
or see, positive and negative are just your state of mind. You can call AB vector as negative, then BA vector becomes,
Positive.
they must be opposite to each other. That is the only scenario. Positive and negative, whenever you talk about displacement, refers to the direction of motion. You want to make it more descriptive. It only depends on the description or direction of motion. So whenever someone tells you the direction, whenever someone tells you displacement can be positive or negative, you can also write it. When someone tells you differentiate between distance and displacement, you can write this with all your open heart. Distance is always positive, but displacement can be positive or negative. But remember, when you're talking about positive or negative displacement, you are talking about its direction. Do we understand this?
Yes.
Yes.
Okay, so this is positive and negative displacement. Now, you might have also heard, see, whatever points we are making, they are also the difference between distance and displacement. Are you getting me? I hope that you understand the difference between distance and displacement. For example, the first point that I wrote was displacement is a vector. So distance becomes
Scalar.
good.
Scalar.
Good. Point number 3. It is a vector. It has both magnitude and direction, but distance only has.
Magnitude.
Magnet.
See, we are writing the same thing. Point number 5. Displacement does not depend on path. Distance.
Depends on path.
In this.
For point number 6, it only depends on initial and final position. Displacement depends on initial and final position, but distance depends on the path. Got it? That is also a difference. Yes or no? Point number 7. Displacement will be 0 if initial and final positions are same. What about this? What about distance?
It is never 0.
It is if something moves, it is never 0. Point number 8. Again a difference. Distance can be displacement can be positive or negative depending on the direction. What about distance?
It can never be negative.
Always positive.
It is always positive. Now you might have also heard about one more thing. You might have heard like this: displacement is always smaller than or equal to distance. Have you heard this?
Yes.
No, remember.
I haven't heard it, but it makes sense.
It makes sense, Rashiki. How does it make sense? Tell me.
Because the displacement can't be more than the distance, no matter what. So.
Okay. Mai, what do you think? You have heard this?
Yes.
Vedansh, do you have heard this?
Yes, sir.
No, remember better. Two things can only be compared. You can only compare Kaushiki with Mahi or Kaushiki with Vedansh because we are all human beings, right? Then I can compare, okay, Kaushiki and Vedansh, how are they? Are they good kids or not? Do they study or not? I can probably compare Kaushiki with her father, how is Kaushiki like her father or not? Or you can compare human beings with each other. Can you compare a donkey and a monkey? No, you can't, right? You can't have a race in which you have a race of someone. I have heard this story that there is a race happening. I mean, three animals are participating in a race, and the race is who climbs the tree first. One participant is a monkey, the other participant is a fish, and the third participant is a lion. Who will win that race?
Monkey.
Because the other two don't know how to climb a tree, right? So I'm trying to compare a monkey and a fish and a lion based on their abilities to climb a tree. Is this a fair comparison?
No.
No.
Similarly, I can't compare Mai with Kaushiki or Kaushiki with that because you are different individuals. I don't compare individuals also. Now, the same thing we are trying to do here. When I write this statement, I'm not against people who have written this, but when you write something, understand what you mean by it. Now, when you're comparing displacement with distance, you are doing a very, very wrong thing. First and foremost thing that we read about displacement was displacement is a vector quantity. And this one is a
Scalar. But I mean, they have the same unit. It's meters.
same unit.
So
I
maybe...
mean, if someone has same unit, does that mean that that thing is same? No. You might have heard about a unit known as a term known as work or energy. Have you heard about it? Work done.
Yeah.
Energy, kinetic energy, potential energy. Heard about it? Mahi?
Yes.
You have heard about it. Then there's also a term which is known as torque. Probably you have not heard about it. They have same units, but torque is a vector quantity. Torque refers to something totally different from work and energy. Is it fair to compare torque with work and energy just because they have the same units? Give me one more example. Apples are sold in India, Kaushiki, not in your place. Apples are sold in kgs, mass, and one more vegetable. Onions are also sold in kgs. They are sold in the same unit. Does that mean that onion and apples can be compared? Can they be compared because they are sold in the same units?
I guess not.
No, no. It's not fair, right? If I compare onions with apples just because they are sold in the same kg unit, that apples and onions are comparable. They are not. They are different quantities. Now, nowhere in my definition that I give you for displacement did I ever mention the word distance. You will say, sir,
No.
you have, but probably while I was mentioning the word shortest distance, I was referring to what is written in your books, right? I refer shortest distance here. Here I refer to it as the shortest distance. But then I was referring to what is written in your books, not to what I was saying. Whenever I talked about displacement, what did I tell you? It is simply AB vector. Yes or no?
Yes.
Or it is simply the
Yes.
displacement or change in position vector. Did I ever use the term distance? Now, if I never use the term distance, can you compare displacement with distance?
No.
No, because that is not a fair comparison. You are comparing onions with apples just because they are sold in kgs. Or you are comparing Kaushiki with Mahi just because both of them happen to be good. And that's not a fair comparison. Distance cannot be compared with displacement, but your books will tell you that if distance is less than or equal to displacement, now you have to understand what they are actually referring to. I'll give you a minute. Think. When someone is saying distance is less than or equal to displacement is less than or equal to distance, can you tell me, now that you know that they cannot be compared, can you tell me what they might be comparing it, what they might be referring here, what they might be referring to here, if they are comparing? In the previous point, we talked about direction. In the previous point, we talked about direction. That is the hint for the next point.
Both of them have length in common.
Both of them have?
Both of them have length in common. So we are comparing the length both of them travels.
Yes, very, very close to reality. Basically,
The
when we are comparing
distance.
here, what we are comparing is magnitude of displacement is always less than or equal to distance. Because when we talk about the magnitude of displacement, we are talking about a length. Yes, when you're talking about the magnitude of displacement, so how will I write it? I will write it as delta r vector, which is my displacement vector, uska magnitude, or I can write it as AB vector ka magnitude, which is the displacement vector. This is always less than or equal to the length or the distance traveled. Are you getting my point, all of you?
Yes.
Whenever someone tells you or whenever you are writing displacement is less than or equal to distance, remember to add the word magnitude of displacement is always less than or equal to the distance traveled. Am I clear?
Yes.
Yes, sir.
Yeah.
That means it is always either less or equal to. Can you tell me the case when they are equal? Remember, when they are equal, when I'm saying, I mean the magnitude of displacement and distance, because displacement can never be same as distance. Both are different quantities. When is
If
the
the
magnitude of displacement same as the distance traveled?
when the path that the distance is traveling in is also the shortest path between the 2 points.
Yoshiki always elaborates the thing. Can you just use one word for it? If the particle is moving in a
Straight line.
Straight.
Yes, that was it, Kaushiki. My well done. If the particle is moving in a straight line, and that is the topic of your class, motion in a straight line. Are you getting my point, everyone? When a body, when a particle is moving in a straight line, then what, Vedansh? The magnitude of displacement is not less than, is equal to L. Do you understand the symbol that I'm using?
Yes, sir.
Kaushiki, Mahi, I'm using
Yes.
symbols so that you get used to this symbol, because these symbols are going to help you a lot. Now, on this point, everyone, let me cite a very good example. Okay, so this is a particle at point A, it goes straight to point B. This is 5 meters. I ask you the first question, what is the distance traveled by the particle, and what is the answer?
5 meters.
Okay. I ask you the next question. What is the displacement of the particle? And remember, when I ask a question, I need the correct answer. What is the displacement of the particle?
Vector AB.
Vector AB. Okay, now tell me something about the vector AB. The magnitude of vector AB, or the magnitude of displacement, is?
5 meters.
Very good. Very good. And the direction of displacement is?
From A to B.
Very good. The direction of displacement is from A to B, and the magnitude of displacement here is 5 meters. So you understand, the magnitude of displacement is compared with distance. It has got nothing to do with the direction of displacement. Do we understand this?
Yeah.
Okay. Now, my journey does not stop here. The particle does not go from A to B and stops. It comes back to point C. This is 2 meters. Now, I again rephrase my question. From A to C, mark my words, A to C. From A to C, what is the distance traveled by the particle?
7 meters.
7.
We all agree, Vedansh?
3 meters.
3 meter. How did you get 3 meter? You go 5, you come back 2. So you subtract 2 from 5. Can distance be negative? Vedansh?
If we go direct to C, then 3 meters.
Did I say I go direct to C? I said I go from A to B. My journey does not stop. I come from B to C. What is the distance traveled? A to B and then from B to C.
7 meters.
पक्का? Lock करें?
Yes, sir.
चलो lock किया. Now the next question, and listen to the question carefully. What is the displacement of the particle?
3 meters from A to C.
3 meters from A to C. That means what Mahi is telling me very precisely now, that the magnitude of displacement is 3 meters. Am I correct, Mahi?
Yes.
And the direction of displacement is from A to C, correct?
Yes.
Problem here.
No, C to A.
No, I go from A to C. Na? A is the initial position, C is the final position. So what will be my direction?
Okay, yes. A to C.
A to C. Kaushiki, Vedansh, you understand? A to C?
Yes, sir.
Yeah.
Magnitude of displacement is 3 meters. And the direction of displacement is from A to C. Now there is a problem here. What I wrote in the green, what I wrote in greening. When a particle is moving in a straight line, I simply wrote, then the magnitude of displacement is always equal to distance. Is it coming the same here?
No.
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 Okay, this is one example. Let me move on to another example. Do you know something known as the Pythagoras theorem?
Yeah.
Mahi? Vedansh?
Yes.
Vedansh?
Yes, sir.
Well done. Here comes my second question. I again go from A to B. Oops. This is 3 meters, straight line. Then I go from B to C. 4 meters. Straight line. Remember, I'm moving in a straight line. No, tick, 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 tick. I'm moving in a straight line. Now again, listen to my questions. What is the distance traveled by the body from A to B, B to C, complete journey?
Distance is 7.
I don't have to say direction. It is simply 7. What about displacement?
It will be A to C.
Displacement ka, let me talk about two things. Displacement ka magnitude. So instead of writing like this, I'll write displacement ka magnitude. What is the displacement ka magnitude? I will have to draw a
Distance
straight.
between A to C.
I will have to draw a straight line like this, right?
Yes.
This is the hypotenuse, yes or no?
Yeah.
Yes.
This is the base and this is the perpendicular. And you know that hypotenuse square is equal to perpendicular
The
square
root
plus
of
base square.
21.
Or hypotenuse will be root over 3 square plus 4 square, yes or no? You all know this?
Yeah.
3
Yes, sir.
square
Root.
plus 4 square ka under root. So it will be 5, yes or no?
Yes.
So displacement ka magnitude is 5 meters, yes or no?
No,
Yes.
it's root.
Root over
No.
25. 5.
No.
No? Sure?
Wait. Oh, sorry.
Okay. Okay. Displacement ka magnitude is this and direction is where? Mahi?
Direction from A to C.
A to. Remember what I wrote here. I am moving in a straight line. I am still moving in a straight line. Case number 1, I moved in a straight line, but my answer was not same. Case number 2, I again moved in a straight line. Well, one case answer is 7, the other case answer is 5. That means something is wrong. I must add
Well,
something here.
to be fair, I never said that. I said that the displacement was equal to the distance. The distance was equal to the displacement between the initial and final position. I never said that it was the straight line. So.
Okay. No, but it only happens in the case of a straight line, beta. But there's only also one more condition I must add. And the important condition is and never changes direction. समझ में आया? It should never change its direction. It should just keep on moving straight. Never change its direction. Here why the thing went wrong? Because when it was going from A to B, it was going like this. But from B to C, it started coming like this. It changes direction. And that is why distance and magnitude of displacement become different. Here also, from A to B, thing was great. From A to B, distance traveled is 3 meters. From A to B, displacement ka magnitude is also 3 meters. No problem. From B to C, distance is 4 meters. Magnitude of displacement is also 4 meters. The problem is when you go from A to C, you have turned. And once you have turned, changed direction, things happen. So distance and magnitude of displacement will only be same in one very, very, very peculiar case. And what is that peculiar case, all of you?
When it moves in a straight line and doesn't change direction.
It just keeps on moving in the same straight line, always, straight. Does not go anywhere else. Am I clear?
Yes.
Will you remember this?
Yes.
So what we have discussed today, we have discussed in great detail about what is displacement. If you have understood this, this is good enough for you to even crack IIT JEE. So I've told you whatever you needed to know till that level. No one will tell you these many things in so much detail. I have told you so that from the very first day, you know what you are encountering. As soon as you think about distance, you think about length of path, you think about a scalar quantity. As soon as you move on to displacement, you think about vector. It has magnitude, it has direction, It is change in position vector. It is a vector drawn from A to B. It has a direction, and distance and displacement are not related to each other. You cannot compare them. The only thing that you can compare is the magnitude of these things, magnitude of displacement and distance. And in only one case they are same. When are they same?
When the distance or the magnitude they travel is in the straight line and direction is not changed.
You have just missed two words. When the particle moves in a straight line without ever changing its direction. Otherwise, distance and displacement have got nothing to do with each other. They are totally different things. Distance is length of path, displacement is change in position. They have been defined differently. They cannot be the same thing. Never, ever again. Do we understand this?
Yes.
Okay, on that note, I will end today's class. So in the next class, probably I'll take it on Monday because we are a bit behind our schedule. Probably on Monday, 4 o'clock, I'll again take you, I'll again take you ahead. And 1 or 2 weeks, we should be good enough according to your syllabus. Okay. So I'll wind up today's class here. If you have anything, you can ask me.